Hi Aryan, how are you doing?
Hi, I'm doing good. How are you?
Very good, very good. So after a class on trigonometry, I hope you must have been in a position to answer most of the questions from your book. Are you in that position or no?
Yeah, I was able to solve a good amount of the questions. There's still a few questions that I'm still a little bit like confused on how to do, but for the most part, I feel good.
Okay, so let's take up the questions which you still are not very clear about. But I'm glad
Yeah.
that you have picked up very fast. Okay,
Okay.
great. So you want me to share your questions, right?
Yeah. Yeah.
Share on my drive. Okay, let me just share. Okay, there we go.
Yeah.
That is the question for
Yeah.
you. Okay,
Yeah.
fine. So from where do you want to start today?
Yeah. So it's question 9 and question 12.
Let's begin with question 9.
Okay. Yeah.
Can you please read the question?
Yeah. A group of RHS students decided to study the sinusoidal nature of tides.
Mhm.
Values for the depth of the water level were recorded at various times. At t is equal to 2 hours, low tide was recorded at a depth of 1.8 meters. At t is equal to 8 hours, high tide was recorded at a depth of 3.6 meters. A. Sketch the graph of this function and write the equation expressing distance in terms of time b given the depth of water at t is equal to 21 hours.
Okay, given the depth of water at, okay, give the depth of water at t equals to 21. So t equals to 21, we have to find what depth of water. That's your question, right?
Yeah.
So we are flexible about it. We could write a sine equation or a cosine function for this particular thing, correct?
Yeah.
So let's review the situation. So the values of the depth of water level were recorded at various times. At t equals to 2 hours, tide was recorded at a depth of 1.8 meters. At
Yeah.
t equals to 8, high tide was recorded. So high tide was recorded at 8, right? This is high tide.
Yeah.
That is the low tide, so the lowest point. So
Yeah.
let's make a function because we will start with high tide.
Yeah.
I make a couple of this. Perfect. Now we are given that the low tide is at 2, 1.8, and the high tide is at 8, 3.6. Is that clear to you? Now,
Yeah.
how do you find time period from here? These two things give you half the wave, right?
Yeah.
Half the wave. So let me write now, half the time period is basically equal to 8 minus 2.
Yeah.
So time period is 6 times 2, which is 12. The value of k will be 2 pi by t, which is 2 pi by 12, or pi by 6. Clear?
Yeah.
Now we have a maximum of 3.6, minimum of 1.8. So average, which is the axis, is basically add them up and divide by 2. How much you get?
Yeah. Um. Yeah. It's just 2.4.
Right. So it is
Yeah.
stable, right? Okay.
Yeah.
Now, maximum minimum amplitude is what? Amplitude is their difference, 3.6 minus 1.8 divided by,
Oh, 2.
how much you get?
0.9.
So I think we have all the parameters except for phase shift, correct?
Yeah.
For phase shift. Now, it depends really what type of wave you want to pick. Since we are given the information right here as a minimum point, correct? we can consider that to be a point of reference for giving the minus cosine function. So I will give you two equations on this. I'll say y equals to. So because we are working with maximum and minimum, we should write the equation in cosine. Is that okay?
Yeah.
Equals to a cos of k, and we're talking about, uh, I should write d actually instead of y, right? So I'll make it d. Okay. So time t minus some phase shift. Let me write p plus q. Now in this particular case, equation one, we are considering minimum.
Yeah.
This will give you a fairly good idea about how exactly we should go about. Now, we are defining the parameters as d and t. So output here is basically d, right? So output is d.
Yeah.
We're saying distance d, depth, I should say, depth is amplitude is given to us as 0.9. Cost of
Yeah.
k we calculated as pi by 6. And t. Now, if I'm considering minimum, in that case, that minimum is occurring at 2, right?
Yeah.
So I'm writing this minus 2. And since I have seen minimum, I am writing minus here also. So cost phase normally start with maximum. Since it is starting from minimum, I will take it as minus 0.9. You get this idea.
Yeah.
Plus the x's, which is 2.4. That could be one of my equations, right? So I'll call this as my one of the equations, which is also correct equation. Now let me give you another equation. Now I'll consider the maximum this time. So when you are starting with maximum, it is the cosine wave as such, correct? So now
Yeah.
I write d as positive 0.9 of cos k value being same, and that maximum really occurs after 8, correct? Now you see that the time period is 12. So that is fine. We'll do that t minus 8
Yeah.
plus 2.4, right? So either equation you could use, both are correct equations.
Yeah. Yeah.
So I've written both are equivalent equations. Both are correct, both are equivalent, right? Now you
Yeah.
understand we did not really calculate anything else. It is given
Yeah.
all that. But we have taken a decision. Since we are working with maximum or minimum, we should write cosine function. And phase shift is directly given from those independent values of time, correct?
Yeah.
Now, you can solve this part B. Now, sketch the graph of this function and write the equation expressing distance in terms of time, right? Actually, should have
Yeah.
depth in terms of time. B, give the depth of water at t equals to 21. So you can plug in t21. Can you find the answer? Depth at
Yeah.
21? Yes, calculate. Use any one of them. Which one do you want to use?
I'll just use cosine because there's a negative for the
The second one, right?
yeah.
Yeah, use second one. So t at, we want to put t as 21. Just plug in 21 here, right? So what do you get? 0.9 cos of radian, right?
Yeah.
Pi by 6, 21 minus 8 plus 2.4. Calculate and tell me the answer.
Yeah. Yeah. It's 3.179.
Correct. So we'll
Yeah.
say 3.179. That is the answer for part B. Now, in between, we also have here to graph the function. So part A is graph the function. To graph the function, we should find what was the depth at t equals to 0, correct? So also calculate
Yeah.
the value at t equals to 0. So at t equals to 0, what is the depth, right? D equals to 0.9 cos of pi by 6 times minus 8 because t is 0 plus 2.4. Correct? Calculate this.
Yeah.
Cos is an even function, so don't bother about minus. Okay? So point,
Yeah.
yeah, point 0.9 cos of within brackets 8 pi divide by 6 bracket close plus 2.4.
Yeah.
What do you get?
Yeah. You get
1.95. Perfect. So clear your memory. There's something wrong. Uh, it retains something in the memory and that gives problem. I don't know. 1.95 because I did
yeah.
get your answer also.
Yeah.
Okay. Now, so the graph is there. The only thing is that we have to draw the axis and seem that the axis somewhere here, right? Of course, when you have a real graph paper, because we know 2.8 will accurately graph it, correct? And this height is 1.8, that is this. So let's say that is my EX. Is that clear to you?
yeah.
And T is in hours. Is that clear?
Yeah.
So that is how you are going to sketch. And of course, this point is 1.95 for you.
Yeah.
So that becomes the sketch. Absolutely clear, right?
Yeah.
Perfect. And remember, when you're given maximum and minimum, that is half the way, right? So half the time period is the difference of maximum minimum. And that is how we got the time period. And from there, we calculate the value of k, correct?
Yeah.
Okay, then let's clear this. And let's move on to next question is which one? You want to do 12, right?
Yeah.
12. Okay, 12, this one. Okay, fine. Can you please read the question?
Yeah. A particle travels along the x-axis according to the position s of t is equal to sine 4t, where t is in seconds and s is the x-coordinate of the particle. A. What is the x-coordinate of the particle at time t is equal to 7.4 seconds? B. What is the largest value for the x-coordinate given position of the particle? C. What is the frequency of this motion?
Correct. Now, let's start from the beginning. Try to understand. A particle travels along the x-axis according to this particular uh, position, right? So we are given position vector, right? So, so along the x-axis, how far is it with time? Where t is in seconds and s is the x-coordinate of the particle.
Yeah.
Okay. So t is in seconds. So you have to put t in seconds. So at t equals to 7.4, if I put that directly, you get the position s of t, which is
Yeah.
7 into sine of 4 times 7.4. Can you calculate this?
Yeah.
Radians.
Yeah. 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 It is negative 6.79.
Negative
79.
6.79. So basically, let's try to understand what is happening here, right? So why it is negative, right? So let me sketch that part here. Let's say, think like this. This is your position, right? And with time, the particle is moving like this. Particle is actually going, let us say, when the time is, I mean, zero, it will be, of course, zero. But as the time increases, it is going to be positive and then negative. So the particle moves like this, goes going like this, right? With time, then comes like this. Do you see that?
Yeah.
So that is the type of movement. So that is why you're getting confused. So that is the x direction in which the object is moving. So we are measuring the displacement s of t from this position. If it is on the
Yeah.
left hand side, it is positive. and negative on the left-hand side. You get the idea?
Yeah.
So that's a movement. So at
That's
any given
yeah.
time, it could be positive, negative, zero. It like oscillates at this point. You get the idea, right? So
Yeah.
strictly speaking, with time, what is happening? Now I'm going to stretch the movement, right? So the particle actually may go like this, come back kind of like this. Is that clear to you? Kind of like
Yeah.
this.
That's good.
All this is happening along one line only, but just to give you a visual with time, I'm stretching it, right? Just to give you that look, correct? And that looks like the sine wave. You get the idea.
Yeah.
That is why we have the term which is along the x-axis, right? This is
Along. Yeah.
x-axis, correct? So horizontally it is going, right? You can treat this as going north and south. To be, you could also treat this as kind of going north. You see that? And then it goes back, it is south, but on the same highway, correct? On the same highway, you're oscillating kind of. Think like this, right? It could be a road, right? And let's say once you go one direction, the other time you come to the other direction. Okay, so that's what it is. So we found that
Yeah.
it is negative 6.79. Of course, the maximum value is 7, right? So in
Yeah.
essence, as we can see from here, the maximum value it will go up to is plus 7 and the minimum which it will go to is minus 7. So your value is going to be between plus and minus 7. You get the idea? So
Yeah.
6.7 is very close to the uh, farthest left side of the reference frame. Okay, so this is also called the reference frame
Yeah.
or a coordinate, right? Okay, so let's read this once again. So a particle travels along the x-axis according to the position s of t equals to 7 sine 4t, right? Where t is in seconds and s is the x coordinate of the particle. Now you understand x coordinate, right? Along the x-axis, it could be 1, 2, 3, 4, 5, 6, 7, or on the left side, minus 1, 2, minus 7, correct?
Yeah.
Now, what is the x coordinate of the particle at t goes to 7.4? We just plugged it in and found our value. Correct. And B, what is the largest value of x coordinate giving the position of the particle? Largest value is 7, right?
Yeah.
Okay, C, what is the
See. Yeah.
frequency? So frequency,
What's the
you know, it is
frequency of this movement?
oscillating, correct? So
Yeah.
frequency will be given to us from the equation itself, which is, we know K is equal to 4, correct? And time period T is 2 pi by 4, correct?
Yeah.
Frequency is 1 over time period. So frequency is 1 over T, is reciprocal of time. Time is, let's try to understand the two terms. When we say T, the time period, let's understand. Time period is time taken for one revolution, one cycle,
Yeah.
right? And frequency is number of cycles.
Yeah. So, in
It
school we were taught. Yeah. Sorry.
Yes, say
So, in school we were taught that the frequency is just one over the period.
yes,
So, yeah, is that how we would just do it, like using our period? Like, because we don't really. Oh no, we do have a. Yeah, we can derive a period here. Our
yes,
period would just be pi over two. So,
correct,
would it just be one over pi over two?
correct, correct. That is what it is.
Okay.
So yeah. So frequency is 1 over t, as you're just now saying. You calculate it, simplify 2 pi by 4 as pi by 2, correct? And therefore, frequency will be 1 over pi by 2, so which is 2 by pi. Is that clear? So we have the answer here, and that is that the frequency f is equal to 1 over time period, which is 1 over pi by 2, which is 2 over pi. cycles per second. So unit will be cycles or hertz, right? Cycles per second. And also we have a name to this and it's called hertz, written as HZ, hertz. Is
Yeah.
that clear to you?
Yeah, that's clear. Thank you.
So
Because
that's a new concept for you. That's why I think you had difficulty in understanding. Perfect.
yeah,
So this question was very interesting since you know what? We have terms which are very confusing. We are moving two things along the x-axis. We are saying, well, the object is moving along the x-axis. Independent variable is time, which is also moving. We assume it to be along the x-axis, correct? So that creates a confusion. However, if you split the problem as we have just done on the right-hand side like this, it should help you to understand the whole scenario. Perfect.
yeah,
Great. Now, tell me, what is your next question?
yeah. So those two were really just the questions that I needed to like help with, like understanding, because like they were written like a little like deceiving.
Yeah,
So those are the two. So since we finished with this,
yeah, yeah.
um, there's a I think there's another worksheet that
Sure,
that we can just
sure,
start.
sure.
I didn't add it in there, so I'm just doing it right now.
Okay.
Yeah, 1 second. I'm just downloading it and putting it in the
Yeah,
file.
then I can share that. No problem.
Yeah, more complex word problems while just making out our graphs and finding what we need to find when asked.
So whenever you have a word problem, I'll recommend that read it twice. Once you
Yeah,
read it to get the whole idea and a picture, visualize what exactly it is, make a rough sketch on the side. Once you have a rough sketch, then you again read it. While reading, place all the values given in the word problem on your graph, right? So you have all the values set there. Then you start working on it. So first thing is, first draft reading should be related to your visualization. Make a sketch. Then again, read it carefully. Mark all the values given maximum at this time, that much, minimum at this time, this much, right? And what do you need to figure out? So once you have these things in mind, then
yeah,
you start working on it. It'll be very easy, just as
yeah,
it was in this case, correct?
yeah.
Perfect. So we'll end our class here today, and I hope you are able to do more and more questions with this. Feel free to share all your questions with me. Okay. Thank you.
Okay, yeah. Thank you very much.
All the best.
Have a good evening.
You too. Thank you.
Bye.